converse of the theorems, which is the if and the then parts of a theorem. So in the Pythagorean theorem, we have if you have a right triangle with a hypotenuse of length c and legs of length a and b, then a squared plus b squared equals c squared. So if we were to look at the converse of the Pythagorean theorem, we would switch the if and the and parts. So if a squared plus b squared equals c squared, then you have a right triangle. So basically, we're going to start with a set of edges, and it's our job to determine if that would make a right triangle. Well, for 9, 12, and 15, we know the hypotenuse is always the longest one, so we're going to fill that in for C. A and B are fairly interchangeable, so we'll just keep that in order. We'll keep 9 as A and 12 as B. So now let's go through and evaluate. 9 squared is 81, 12 squared is 144, and 15 squared is 225. So if these three edges will make a right triangle, then 81 plus 144 equals 225. And sure enough, when we add those two values together, we do get 225. So here, the converse is true. These three edges would make a right triangle. Let's try it with another set. Here we have 11, 8, and 8. Well, again, we know that our longest edge is going to be our hypotenuse, so we're going to fill that in for C. 8 and 8 are A and B, so it doesn't matter which order we put them in, we're just going to fill them into our equation. Now we can evaluate. 8 squared is 64, 8 squared again is 64, and 11 squared is 121. So if the converse is true, 64 plus 64 would equal 121. But when we add those together, we get 128, which is not equal to 121. So this tells us the converse is not true. Edges that are lengths of 8, 8, and 11 could not make a right triangle. Check out the other videos in our playlist and don't forget to click on subscribe. Thanks for watching!